I'm sorry.
2x squared plus c is equal to 4. At x is equal to 8 plus c is equal to 5.
Alright, so hopefully you know how to find those area under the graph and stuff like that. We already go through enough of those, so we're gonna keep on going. And a lot of people are not here today, so I'm making video for Anthony and Ariana. Ariana, show up to class. According to Instagram, you are sick, but I know you couldn't be here.
She's absent.
So show up. I don't care if you're dying.
Right now.
It's funny you assume she'll watch this.
Bro, she came down with the common cold.
And don't even think about dropping the class because I won't let you drop.
Are you sure you want that on camera?
Huh?
He's calling her out.
Okay, so this is your new equation.
So one of the homework, a lot of you guys have problem with number 4,
And then you just gotta solve for c.
right? So what does number 2? Number 4 says d2y dx2, that's equal to 4x.
Y equals 4x plus 8.
It's like, how do you get that from that?
Okay, so no, that's
And then
two
it's like x
different
equals
things.
2.
That's given.
No, it's
So they say this one is the tangent line of this graph, right? They say that? So what does that do is, this one you also notice, this is f double prime of x. And f double prime of x is equal to 4x. Now if I integrate it, it's going to be f prime. Does that make sense? So we know there's a arbitrary graph. We don't know what a graph looks like. We know it's probably, if you integrate this, it's going to be second degree. And if you integrate again, it's going to be third degree. So it's probably a third degree polynomial. Now third degree polynomial has a tangent line of this one at x equal to 2. So what happened is at x equal to 2, this one is the tangent line. Okay, so that means if I were to integrate this, I'm going to get integrate of f double prime of x, that's equal to f prime of x plus c. Right? We're going to have some type of f of x plus c, but we don't know what a c is. But, so we know that if I integrate this 4x, that's equal to 4x squared over 2 plus c. So some type of c, and that's going to be equal to f prime of x. But since f prime of x has at x equal to 2, it has this slope. So this just means f prime of 2. So the only thing about this is extracting information. F prime of 2 is equal to the slope, which is a 4. If you tangent line to each other, they both have the same slope. The equation and this one have the same slope. So therefore, f prime 2 is equal to 4. But that also, the tangent line, if something is tangent line to each other, right? If something is like tangent line to each other, they have the same slope as well as they have the same y value. So then you can plug in 2 into this, you can get a y value. So that means f of 2, that's equal to 16, I think. Is that right? So that's it. So this is the hardest part, is extracting this information. Because if you have some arbitrary graph, right, some type of arbitrary graph, I have at x equal to 2, that does a tangent line at, oops, that was a horrible tangent line, but I have tangent line at here, and this tangent line is y equal to 4x plus 8. Some arbitrary graph like, I don't know, like this, like this, and I have tangent line at this point, at 2. So therefore, the slope is going to be equal to each other, as well as the y value is equal to each other. So then, I'm just doing that, so f prime 2, that's equal to 4, so as a 4 is equal to, I'm going to plug in, what? 4 is, I'm going to plug in 2, right? So that's going to be 2x squared, I think?
Yeah, plus
2x squared plus c, but x is equal to 2, so it's 4 equal to 8 plus c is equal to -4. So this one is going to be f prime of x is going to be this, it's going to be 4x squared, 2x squared plus -4. Any question about this part? So that was the hardest part, to extracting this information. The rest of them just arithmetic that you should know how to do. Yes?
I'm still kind of confused as to how you got 16.
So they have some y value, right? So can I just plug in 2 here? So 2 times 4 is 8. 8 plus 8 is 16. The y value is going to be identical because they're touching each other, they have the same y value.
Okay.
Same slope and same y value. That's how the tangent lines work.
Okay.
Okay, so 2x squared minus 4. Now I'm going to take the integration of again, 2x squared minus 4 dx, and that's going to be x to the 3 over 3 to minus 4x plus c, and we know that's equal to f of x. And we say that is equal to 16, plug in 2, so it'll be 2 times 8 times 3 minus 4 times 2 plus c. So eventually you're going to get c equal to 56 over 3 or something like that, and then you can plug in. So should I work it out or no? 16, I might as well. 16 over 3 minus 8 plus c, and I'm going to add 8, so it'll be 24 minus 16 over 3 equal to c. C is equal to 72 minus 16 over 3, which is a 56 over 3. So this one's going to be 56 over 3. And that's my final equation. That was the only one that's kind of hard. The other one is all simple. And this one you've done it before. I go over it before, but you guys should pay attention because it's extracting information. In calculus, not only that you can do calculus or algebra, you need to be able to read the question and extract the information. Question about this part. So, that was one of the things. So hopefully you guys understand all that. And
Don't erase or read all. Don't erase.
Okay, fine. We can look at it, process it, and I'll erase it in a second. So we're going to talk about fundamental theorem of calculus today, but this part is super easy. This is the first part. Fundamental theorem is very easy. It just name is very scary, but it's actually super easy.
Yeah.
Yeah, so it becomes 2x cubed over 3 minus 4x plus
Where did you get that from?
Okay, so basically he used the original equation he did integral of basic ct to the f prime over 4x.
Oh, it is integral of 4x.
So that became 4x squared over 2 plus c, which is 2x.
Any question about this?
And then since he knows that x equals 2x, then it's going to be the same as the tangent.
Can I go to the topic today? Okay, so today's super easy. It's just fundamental theorem calculus. It just talks about a definite integral. A lot of you guys don't understand what is anti-differentiation, what's definite integral and indefinite integral. So we're going to talk about that.
look at, that becomes 2x squared plus 3 plus 4x plus c, and it plugs in.
Yeah.
So it plugs in 2.
Okay, so this one
X is
Yeah.
is f of x dx, between a to b, of node a to b. We call this indefinite integral.
You need to raise it down to 4.
Okay, thank you. This is called indefinite integral because it has no boundary. It has no boundary at all. And we also call this anti-differentiations, anti-derivative. So people have different name for it, which is reverse of derivative. So there's no boundary. But indefinite. So we didn't tell you what a boundary is. If I have between b, a to b, for f of x, now I have a boundary, but there's a different name for this integral. That's called definite integral. Okay, so this is definite because it has a boundary. So it has a boundary. Now, definite integral just means the area to the curve in the x-axis. Okay, so if it's below the x-axis, you're gonna get negative. So the other day we covered when we talked about the geometric way to find something like this between, I don't know, 1 to 5 dx. And we say we can graph this. We can graph x minus 3 functions. And that x minus 3 function is going to look like this. 1, 2, 3. Have my slope of rise 1 over 1, rise 1 over 1, rise 1 over 1, rise 1 over 1, and rise 1 over 1. So I can find the area of the boundary is going to be between 1 to 5. And I can find this area, but I can do this without using calculus, which is, that's a trapezoid. The trapezoid, this height is, if I want to find out the height, I just plug in 1 into this function. Wait, it should be plus 3, sorry. My fault. So it should be plus 3. And then I will have, I plug in 1, I'm going to get this, it's a 4. That's the height. If I want to find out height here, then I just plug in 5 into the function. It's going to be what? 8. So it'll be 4 plus 8 divided by 2. That's the average of 2 base. Multiplied by the height, which is right here. In this case, is 4. So that's equal to 12 over 2 times 4. 6 times 4, that's equal to 24. Now, of course, you prefer to do this way because it seems a lot easier.
You want to do that again, right?
And you also do like the triangle or the
Yeah, but that's not the final way. What if the graph is no longer a straight line? If it's a curve, if it's a sine graph, cosine graph, x cubed graph, x squared graph, you no longer can find the definite integral with geometric way to do it in terms of using geometry formula. Because geometry formula doesn't including if the one of the side is a curve. So therefore you had to use a better way. So we're going to talk about fundamental theorem of calculus. So fundamental theorem of calculus says, well, if you have something that is continuous between a and b, and you can take an integral of that, then you have, so it has to be continuous, okay? It has to be continuous, because it's not continuous, you cannot find the integral. So it has to be continuous, and if I say f of x dx between a and b, that just equal to big F of b minus big F of a. So remember, it's a high bound, or upper bound, sorry. The upper bound and then this is lower bound. So just take integral, I'm gonna get big F of x. Now usually like I will write another thing here, but I'll show you how I would write it. Makes totally sense. So we're gonna try to get 24 with using a way that we learn in calculus. Now unless you're in competition, again, I'm not focused on this, unless you're in competition that you will have to know the definition of integral. But if you are not in that, you just understand fundamental calculus, is good enough. But those of you guys that are going to competition, I will teach you what is the delta x and the left endpoint, right endpoint approximation, and changing in the infinite intervals, and eventually you're gonna get the same answer. So in this case, I'm gonna use the same way. So let's say x plus 5, no, plus 3 dx. Okay, so between 1 to 5. I'm gonna take an integral of this. What's the integral of this? X squared over 2 plus 3x, right? Now, a lot of you guys don't know how to do this. Is after you take the integral, you need to have a notation. A notation is a straight line. That straight line just means you haven't plugged in yet, but it's also including the bound, so it's 1 and 5. So it's very important you write this out, because that way you know you haven't plugged in yet, and you already take an integral. Okay, so I will write that extra line here just to kind of help me. So now I will plug in the 5 into this thing, subtract 1 into this thing. So what I'm going to do is going to be 5 squared over 3 plus 3 times 5. And I'm going to do a bracket minus 1 squared over 2 plus 3 times 1. Any questions about this part?
It should be 5 squared over 2.
Huh?
5 squared over 2.
5 squared over 2. I plug in 5 into this, subtracted plugging 1 into that. It's always upper bound minus lower bound. So here I'm going to go 25 over 2 plus 15 minus 1/2 plus 3. Now, the tricky part is I don't evaluate this, although parentheses told me evaluate this first. But sometimes, because due to they all have the same denominator, I will actually break the parentheses first and combine like term, because you combine like fractions. So here it's going to be 25 over 2 plus 15 minus 1/2 plus minus 3. Why is that so important? Can the screen see the bottom?
Yeah.
Barely.
Yeah, you're good.
Okay, so now what I do is I will combine those two fractions first. So that becomes what? 24 over 2, right? And I combine those two integers first, then that way I don't worry about the thing. So end up, it's worked out pretty nicely. So it's 12. So that's equal to 12 plus 12. That's equal to 24. So it actually turned out to be very easy if you just break down the parentheses and you combine the same like fractions and then combine the integer together. You don't have to evaluate this one, because you're going to get a fraction and you're going to get a fraction and you're going to subtract 2 fractions, so that's getting more messier, where you just have to deal with fractions straight. So the next 3 question I'm going to ask you to do is this. A simple one, it's not hard. It's going to be integration of x squared minus 3 and between 1 to 2. That's the first one. The second one, I'm going to 4 to 9 of 3 squared over x dx. The third one is I'm going to do integration between 0 to pi over 4 of secant squared of x dx. So, and then lastly, this one I'm going to go over it, but you can try it first. It's between 0 to 2 of 2x minus 1 dx. Okay, so try the first 3 first. Huh? That's okay. Since we live in 3 minutes, you should get those three questions. But I'm gonna do the fourth question on the video because you're gonna have some question about the fourth one. We talk about it, and we just never talk about 2x minus 1. We talk about x minus 2. It's two-part triangle. You can add up. But we're also gonna talk about how do we use the new way that we do it and using algebra that we know to solve that problem. First question, if you did it right, you should get a negative number, and it is a fractions, and it is a 5. The sum of a numerator and denominator is 5. Negative, fractions, numerator plus denominator is 5. The next one is 2-digit number, added together, it's also equal to 5. And the one after that is the one with Euler's number. Euler's number, or Euler's equation. The first one is negative 2 over 3. The second one is 14. The third one is 1. I'll go over the last one. If you want to stay away from me, go over the last one. It only take me 3 minutes to do. If not, I'm going to record it. This is equal to negative 2 over 3. This is equal to 14, 1, and I think last one is 5 over 2, I'm not sure. 5 over 2, yeah. But I'm going to go over the last one because the last one you're going to have a homework question about this. And you're going to know how to do it. And there was 2 ways to do it. You had to know both ways. But we're going to talk about 2 different ways. So integration between 0 to 2 of 2x minus 1 dx. So for me, I will just graph this function. But I don't know what the graph look like. But I can find the zeros. How do I find the zeros? 2x minus 1 is equal to 0. 2x is equal to 1. X is equal to 1/2. That's the zeros. So we know the graph somehow is like 1/2. 1/2 is going to be, that's going to be the point. And it's going to have a V shape. So we're going to have some type of V shape. We don't know how high is it. So we're going to talk about geometric way to find it. Geometric way to find it is easy. This is 1/2. How do I find the height of this one? Plug into this. And if I plug into this, it'll be 0 minus 1. Absolute value is going to be 1, right? And if I do it here, this one, the width is 3 over 2. But what is the height? Plug in again. So it'll be 2, 2, 4, 3. So that's going to be 3, right? So this one's 1/2. This one's 3. And you can use the area of triangle to find it. However, this is not what only way to teach you. I want to teach you algebraic way. Algebraic way is this part of function is actually 2x minus 1. And this one is going to be negative of 2x minus 1. We did this before a long time ago. It's 2 times a piecewise function. So you can do integral between 0 to negative 1, 0 to 1/2 of negative of 2x minus 1 plus integral between 1/2 to 2 of 2x minus 1. And you're going to get the same answer geometrically or algebraically. But this one negative sign is easier to take out a negative sign outside, so I will take a negative sign of that. 0 to 1/2 of 2x minus 1 plus 1/2 to 2 of 2x minus 1. You have to make sure you do this separately, and your result is going to get 5 over 2. I'm going to trust you that you can do that. Okay? And that should be all.
Isn't it like 38?
Oh, wait,
You're using different numbers.
Mr. Ye.
Oh, it should be 1 to 4. Oh, this one should be 1 to 4.
Oh, wait.
Sorry, this one should be 1 to 4.
When you're doing a definite integral, is there no plus c?
Oh, that's a good question. Is there no plus c in definite integral? There is no, because the first integral you're going to have plus c. The first one you plug in f of b is going to have a plus c. F of a also has a plus c. The c and c going to cancel out each other. So c is no longer useful. Definite integral, it has no c's. Good question though.